I concluded the last tutorial with the observation that the demonstration I did was a mess, although it did appeal to axioms in a proof system. And that led us to observe that we need a more formal presentation style. So in this tutorial, I'm going to introduce you to a style of formal proof that's fairly common. It's a good starting style. Other systems include some additional features that are useful if you're doing mathematical logic. But this is a really great way to get started on proofs. So let's consider a very basic argument going back to our argument about enchiladas. So if you give me an enchilada, then I'll give you a taco. You are giving me an enchilada, therefore I am giving you a taco. So this is an actual argument. We could derive the schema for that argument in the usual way. P implies Q, P, therefore Q. Now at this point, I hope you are recognizing this schema as modus ponens. The key feature of modus ponens is that we have a material implication as the first premise. So notice it has a proposition on the left-hand side, a proposition on the right-hand side. In the second premise, whatever is on the left-hand side of the implication sign is repeated, and the conclusion draws whatever the consequent is of the material implication. So that's modus ponens. We usually abbreviate that MP, modus ponens. All right, so now let me show you how we can set up a formal proof. So first of all, we're going to number all the lines, including the line of the proof, the premises of the proof that we start with. So the first premise is P implies Q. The second premise, we'll put on the second line with a number, is P. And now we'll skip over a tab and write the conclusion that we're aiming for, which is Q. So this part of the formal proof is, you might think of it as the setup. This is basically setting up the proof. It is the premises on numbered lines, and it gives an indication of the conclusion that we're aiming for by using this convention. So a tab, and then usually there's a stroke and maybe the three dots, and then the conclusion that we're aiming for. All right, so for a moment, ignore the conclusion that we're aiming for, and notice that in lines 1 and 2, we have the premises of modus ponens. So if we were to apply modus ponens, that's a way of talking about it. If we were to apply the pattern modus ponens to these two premises, look what we would have. We'd have the left scope of the material implication, the right scope, the left scope. In other words, the antecedent is repeated in the second premise. And so what would you expect as the conclusion of that application of modus ponens? You'd expect the consequent of the implication that is in the first premise of modus ponens. And sure enough, that's what we can say here. But what is that consequent? In this case, the consequent is everything that's in the triangle here gets repeated here. So we write Q. Now, how did we get that Q? We got it by applying the pattern modus ponens. We have the two premises in lines 1 and 2. We apply modus ponens, and we're able to derive the normal conclusion of the modus ponens, whatever is in the triangle. So on line 3, we write that conclusion of that application of modus ponens. We skip over a tab, and we give our justification. We applied modus ponens, and then a dash, and then we give the premises that we applied modus ponens to by indexing the line numbers. So we applied modus ponens to lines 1 and 2 in that order. Why 1 and 2 in that order? Well, because 1 corresponds to the first premise, that's this, but it corresponds to the first premise of modus ponens, and 2 is line 2, but that corresponds to the second premise of the modus ponens. Okay? Now, what if our original argument had a different order? So, for instance, what if we are looking at this argument? Line 1 is just P, line 2 is P implies Q, and the proposition we want to prove is Q. Okay, so again, that's the setup of the argument. What does that correspond to? Well, a model based on this example would look like this. You're giving me an enchilada, and if you give me an enchilada, I'll give you a taco. Therefore, I'll give you a taco. So you see what I mean? It's the same argument, just a different order. But I'm doing this to illustrate a particular point about formal proof. So our reasoning is basically the same, except the first premise of the modus ponens is now line 2. In other words, it follows exactly the right characteristics for the first premise of modus ponens. The line 1 premise is actually the second premise of modus ponens, the schema modus ponens. And so we're still entitled to draw the same conclusion, which is whatever the consequent of that implication is. And so it's whatever is in the triangle, whatever that scope is. So that's Q. Once again, our justification for concluding Q from the lines up here is modus ponens, but this time we're invoking modus ponens on lines 2 and 1. Now, look at why that is. Line 2 corresponds to the first premise of modus ponens. See, that's the shape of the first premise there, the form. It has to have an implication in it that connects two propositions, which are represented here by the square and the triangle. The second premise of modus ponens is line 1. That corresponds to the square, which is the antecedent of the modus ponens. And the conclusion that we're drawing corresponds to everything in the triangle, which is the consequent of the first premise, which just happens to be line 2 in this proof. Okay, so what we have here is we have two very simple proofs. It uses only one axiom, modus ponens, but in both cases we have provided a formal proof of validity for this argument, or alternately this argument. Okay, so look at the parts. We have all the premises on lines that are numbered. The conclusion is indicated by this symbol right here. The conclusion is what we're aiming for through the application of various axioms. Then everything below the premises, up here, these are the premises, everything below that will be conclusions that we have derived from something above that line. So notice on line 3, we're deriving Q from things above line 3 using some particular rule, which we specify here, and also citing which lines we applied it to in the order that the premises appear in the schema. So there's a number of different elements that are all built into this. We're going to see more of this as we look at the inference rules, they're called. These are axioms that allow us to derive conclusions. So more on that in our next tutorial. But for now, I want to conclude by saying that when we arrive at the end of a proof where we have proved the thing that we set out to prove, it's traditional to write QED. QED stands for quod erat demonstrandum, which means which was to be demonstrated. So it's traditional to write that on the last line of the proof as a signal that the proof has successfully completed.